This Zoom session is being brought to you by the Fractal Tripod Snow Ring Black. All right, here we go. All right. Whoops, wrong one. Oh,
8.1.
7. Excuse me, machine. Come on. Much better. Apologies. Okay, complex numbers. This is, we extend the number system from a one-dimensional line to a two-dimensional plane. And we do that by adding a solution to a new kind of equation. I is the square root of -1. That's its definition. So I squared equals -1. Now the thing is, positive numbers squared are positive. 0 squared is 0, and negative squared is positive. So I can be neither positive, 0, nor negative. It's not on the number line at all. In fact, we put it sideways to the number line. If this is the number line, then I is 1 unit up in the perpendicular direction. That's I, there's -I, 2I is up 2, and -2A is down 2, and so on. But that's just 2 lines. This is called the real axis. Excuse me. This part is called the real axis. This part is called the imaginary axis because we call I the imaginary unit. That's a somewhat unfortunate name. I really would rather be called a lateral unit, but never mind that. And points in the plane itself, like here, over A and up B, like in Cartesian coordinates, we denote it by A plus IB. A is called the real part, B is called the imaginary part, and again, I really would prefer what we call the lateral part, but never mind that. Now we're going to find the arithmetic, plus, minus, times, divide on these numbers, called the complex numbers, denoted by a kind of a bold-faced C. And we're going to define it geometrically and arithmetically. So for example, given two numbers W and Z, we denote them as these points in the complex plane. And if here's the number 0, then we draw the line 0 to Z and 0 to W. Then we draw a line parallel to 0 W along here and parallel to 0 Z along here. And this forms a parallelogram. And the far corner, it will be denoted Z plus W. That's the definition, the geometric definition. The algebraic definition is that given A plus IB, and to it we add C plus ID, and we add the real parts, A plus C, and we add the imaginary parts, I times B plus D. Basically, we're assuming here that the usual laws of arithmetic apply to these new numbers, and this follows from that. We add the real and the imaginary parts in parallel. We subtract them in parallel. A plus IB minus C plus IB, D, we subtract the real parts, A minus C. We subtract the imaginary parts, I times B minus D. Now, here's a way to visualize it. If this is Z and this is W, the minus W is in the same length and in the opposite direction. And we just add these up by the parallelogram law, leaving here for Z minus W, making a letter D for difference. I call it the D rule. To find multiplication in the complex numbers, we use FOIL, first, outer, inner, last, and the defining equation I squared equals -1. That's its definition. It's the square root of -1. So for example, A plus IB times C plus ID, well, at first are AC, outer is A times ID, inner is I times BC, and the last is IB times ID. Now the thing is, okay, so AID, IBC, we pull these together, collect them into I times AD plus BC. AC, and these are I squared, BD. Now the thing is that I squared is by definition -1. So this part equals AC minus BD. So A plus IB times C plus ID equals AC minus BD plus I times AD plus BC. So we do an example. 5 plus I3 times 3 plus I2. I prefer putting the I in front because I personally think that I is more like a sign than a number, plus, minus, I. Although you'll often see it as A plus BI. All right, so multiplying up by FOIL, 5 times 3. I times 3 times I plus times I times 2, I squared is -1, so -3 times 2. 5 times I2, I times 5 plus 2, plus I3 times 3, so I times 3 plus times 3. So this will be 15 minus 6 with the real part, plus I times 10 plus 9 for the imaginary part. So that'll be 9 plus 19i. There. Here's a cute one. A number and what's called its complex conjugate. 3 plus I, 5 plus I3 times 5 minus I3. Okay, real part is 5 times 5. Plus times minus is minus. I3 times I3 is minus 3 times 3. I times 3 plus 5 minus 5 times I3. So I times 5 times negative 3. So we're going to get 25 plus 9 for the real part. The imaginary part will be I times 15 minus 15. The imaginary part cancels out. And so all we're left is the real part, 34. In general, A plus IB times A minus IB. The IAB and the IA times minus IB cancel out. We're left with A squared minus I squared B squared minus I squared is 1. So you get A squared plus B squared. So for example, 3 plus 4i times 3 minus 4i. Well, you get the 3 times 4i and 3 times minus 4i cancels out. 3 times 3, here's 3 squared. 4i times minus 4i, the minus I squared is a plus, so you get plus 4 squared. 3 squared plus 4 squared is 9 plus 16 is 25. Here's 7 minus 2i times 7 plus 2i. Again, with the imaginary parts cancel out. A squared plus B squared, 7 squared plus 2 squared. 49 plus 4 is 53. So in other words, a complex number times this, it's called its complex conjugate, where plus I is replaced by minus I. Number times its conjugate equals A squared plus B squared. We can use this to divide complex numbers. For example, 1 over 3 plus 4i. Now that 3 plus 4i is annoying in the denominator, but we can simplify it by multiplying numerator and denominator by 3 minus 4i. We rescale by the conjugate of the denominator. Multiplying across, 1 times 3 minus 4i is 3 minus 4i. 3 plus 4i times 3 minus 4i is sum of squares, 3 squared plus 4 squared. So 3 minus 4i over 25, or in other words, 3 25ths minus I times 4 25ths. That's this. And here we have complex divided by complex. 1 plus 3i over 7 minus 2i. We'll rescale, that is, multiply numerator and denominator by the conjugate of the denominator. 7 minus 2i, its conjugate is 7 plus 2i. And now in the top, 1 times 7 is 7. 3i times 2i is minus 6. 3i times 7 is 21i. 3i times, 1 times 2i is plus 2. And in the denominator, 7 minus 2i times 7 plus 2i is 7 squared plus 2 squared. So in the numerator, 1 plus I times 23 over 53. So 1/53 plus I times 23/53. So we have examples from the book. 6 minus I times 9 plus 3i. Well, we have the real parts, 6 plus 9 here. You have the imaginary parts, minus I plus 3i is I times minus I plus minus 1 plus 3. So 6 plus 9 is 15 plus I times 2 is this. Here we subtract real and imaginary parts. 7 minus 4 is 3. Negative 3 minus negative 2 is a negative 5. So 3 minus I times 5. Now we multiply. 2 plus I times 3 minus I. First is 2 times 3. Outer, and then there's I times minus I. So it's minus and negative I, 1 times 1. I times 3. I times minus 2. So this is 6 plus I times 1, or 7 plus I. This is the square of a complex number. 2 plus I squared, or in other words, 2 plus I times 2 plus I. So 2 times 2, here that's 4. I times I is a minus 1. I times 2 plus 2 times I, it's I times 2 plus 2. So this is 4 minus 1 is a 3, plus I times 2 plus 2 is 4. 3 plus I, 4. Here's a ratio of complex numbers. 3 minus 2i over 4 minus I. We multiply above and below by the conjugate of the denominator, 4 plus I. Multiplying on the top, 3 times 4 here, minus 2 times negative times 1 is a minus a negative 2. Minus 2i times 4 is a minus 8i. 3 times I is a 3. Meanwhile, 4 minus I times 4 plus I is 4 squared plus 1 squared. So this in the top is 14 minus I times 5. It's over 16 plus 1. So 14 17ths minus I times 5 17ths. 5 plus 9i over 1 minus I. We'll multiply numerator and denominator by the conjugate. 1 plus I over 1 plus I. 5 times 1 is 5. 9i times I is a minus 9. 5 times I is 5i. 9i times 1 is 9i. 1 minus I times 1 plus I is 1 squared plus 1 squared. So this gets a negative 4 plus I times 14 all over 2. And after a bit of reducing, this is minus 2 plus I times 7. Minus 2 plus I times 7. Here we have the square of 4 minus 8i. So write that as, well, you can write it as a square of a difference is square minus twice product plus square. Square minus twice product plus square. 4 squared minus twice 4 times 8i plus 8i squared. That's 16. This is minus 64i. This is minus 64. 16 minus 64 is minus 48. So minus 48 minus 64i. Here they have one of those look-alike problems. We square here at 2 times I, and here we square 2 plus I. Square of 2i, well, it's 2 squared times I squared. That's negative 4. 2 plus I all squared, that's square plus twice product plus square. 2 squared plus twice 2 times 2 plus I squared. This is 4 plus 4i minus 1 makes 3 plus 4i. All right. That concludes this section and this chapter.